All right, get ready to dive into something pretty cool today. It might make you rethink what you thought about candy and earthquakes.
That's a pretty interesting combo.
Yeah, well, we're talking about triboluminescence. It's light, but it's made by, like, mechanical action.
Light from breaking and rubbing, basically.
Exactly. I know, it sounds kind of sci-fi, right? But it's totally real.
Absolutely. It's a fascinating area of science. We're talking about taking mechanical energy, like the energy of movement, and turning it into light energy.
Yeah, it's like crushing or rubbing something. It can be light. It's wild.
It is remarkable when you think about it.
So we got a bunch of research on this, and it's full of these cool little facts, ready to uncover 5 things about triboluminescence. Things that will make you see everyday stuff in a whole new way.
Let's shed some light on the subject, literally.
Okay, so first let's break it down. Like, what's actually happening that we crush things and they glow? What's the science behind this light from breaking thing?
Well, it's all about energy changing, but on a super tiny level, like atoms and stuff. When you bite into a hard candy, for example, you're breaking the chemical bonds in that candy.
Oh, okay.
And when you break those bonds, it releases energy. Some of that energy excites the electrons in the material.
Excited electrons, like they're ready to party or something.
Pretty much, they jump up to a higher energy level, but they can't stay there forever. So as they fall back down to their normal state, they release that extra energy, and sometimes that release comes out as light.
So that's what we see, the flash, the electrons calming down and giving off light.
Exactly. Now, how bright that light is, like if it's just a faint glow or a big spark, that depends on the material and the environment.
Okay, that makes sense. So let's talk about sugar. You know, the stuff in our coffee and cookies, it doesn't exactly screen glowing substance.
You might be surprised. Regular table sugar, the kind we use every day, actually gives off a faint glow when you crush it. It's usually too dim to see in normal light.
So I need a super dark room to see sugar sparkle.
Pretty much, you might catch a glimpse of it if it's really dark.
Why don't we see a light show every time we scoop sugar then?
Well, the amount of light sugar makes is really small. It's about how well the material turns mechanical energy into light energy. And sugar isn't very good at that. Not all materials are the same in that way.
Interesting. Which brings us to the superstar of triboluminescence, right? Wintergreen lifesavers. These candies actually spark when you crunch them. What's the deal with that?
It's a few things, actually. The sugar crystals themselves are doing the triboluminescence thing, just like we talked about. But wintergreen lifesavers have a secret ingredient, wintergreen oil.
Ah, okay.
And that oil, it's fluorescent, so it takes ultraviolet light, which we can't see, and turns it into visible light.
So it's a double whammy. The crushing makes the first light, and the oil makes it brighter so we can see it.
Exactly. It's super cool how these two different things work together to make a bigger effect.
Okay, that's awesome. So we've got crushing, we've got glowing. But what about other ways to make this happen? You said rubbing can also do it.
Yeah, that's right.
So like rubbing 2 wintergreen lifesavers together would make sparks fly.
That's a fun thought, but it's not quite that simple. Rimming can make triboluminescence in some materials, yeah, but how it works is a bit different from the crushing thing.
Okay, I'm curious now. What's different about the light from crushing versus rubbing?
With rubbing, we're usually talking about something called frictional luminescence. It's like triboluminescence's cousin, but the way those charges, those electrons, get made and separated is different.
Okay, so it's not just about breaking bonds, like with the candy.
Right. Imagine rubbing a balloon on your hair, you know?
Yeah, classic.
It makes static because electrons go from one thing to the other, and sometimes that moving around of charges, that separation, can make tiny little sparks of light.
Oh, so like when you pull off a sweater in the dark and you see that tiny spark. That's this rubbing light thing.
It could be. Not always, but yeah, that's a good example of how these cool light effects happen in everyday life.
This makes me think about piezoelectricity. That's about separating charges to make light too, right?
You got it. Piezoelectricity is super cool. It's when you squeeze or press certain materials, like some crystals, and that stress separates the charges.
Wait, so squeezing your crystal can make it spark?
It can, yeah, under the right conditions. The pressure changes the crystal structure so the charges get all rearranged. That creates like an electrical potential. And if the voltage gets high enough, boom, a tiny spark.
So the crystal's like a tiny battery, storing energy and releasing it as light.
That's a good way to think about it. It shows how mechanical energy, electrical energy, and light energy are all connected.
It's wild how it all ties together. We started with a candy spark, and now we're talking about crystals making electricity and light.
And it gets even bigger. What if triboluminescence is happening on a huge scale, deep inside the Earth?
Wait, are you talking about earthquakes?
Bingo. Some scientists believe triboluminescence could be happening in rocks during earthquakes.
So the ground shakes, rocks brine together, and sparks fly miles underground.
It's a pretty intense thought, right? It shows how powerful this thing can be. The forces in an earthquake are massive. So yeah, those conditions could totally break bonds and excite electrons in rocks and make light.
But how would we even know if that's happening? We can't exactly put a camera down there during an earthquake.
True, seeing it directly is tough, but people have reported weird lights during earthquakes for a long time, and some scientists are doing experiments in labs trying to copy the conditions of an earthquake and see if rocks make light.
So we don't have solid proof, but the idea of earthquake light is super intriguing. It adds to the mystery of those powerful events.
It does, and it shows how much we still have to learn about the Earth and what makes it tick.
Speaking of learning, this deep dive has gone from tiny atoms and electrons to giant earthquakes. It's amazing how one phenomenon can connect so many different parts of science.
It shows how connected everything is in nature. It's a reminder that even everyday things can hold these amazing secrets.
So where do we go from here? What else can we find out about triboluminescence?
Well, we've mostly been talking about natural triboluminescence, but what about using it for stuff like technology?
You mean like making new things that use triboluminescence?
Yeah, exactly. Remember piezoelectricity? We use that in tons of stuff already, like watches and medical imaging.
So could we use triboluminescence in the same way, make things that light up using movement?
That's a really cool idea. Imagine lights that turn on when you press them, or sensors that detect stress by glowing. There's so many possibilities.
It's like turning every step, every touch into light. That's mind-blowing.
It is. It shows why it's so important to keep researching this stuff. Who knows what we'll find if we keep digging.
It feels like we've just scratched the surface of what triboluminescence can do.
Absolutely. And as we learn more, I think we'll find even more surprises and connections that help us understand the world better.
Speaking of connections, get this. There's a link between triboluminescence and, wait for it, the FDA, the Food and Drug Administration.
The FDA? Really? What do food rules have to do with light from breaking stuff?
It's not a direct link, but it brings up some interesting points about how people see science and how we talk about it. Remember red dye number 2?
Oh yeah, the food coloring that got banned even though it was safe, just because of how people reacted and how the science was explained.
Exactly. That shows how important it is to explain science and clearly and accurately, especially when it's something people can get the wrong idea about.
So you're saying scientists studying triboluminescence have to be careful about how they present their research, just like the FDA has to think about public perception with food.
Exactly. Imagine the headlines if scientists said earthquakes cause sparks without explaining it properly.
Earthquake lights, are they real or a sign of the apocalypse? Yeah, I can see it now.
It shows how important it is to communicate science well, especially when it's something people might misinterpret or overreact to.
Absolutely. It's about balancing scientific curiosity with responsible communication.
And on that note, let's talk about something else cool about triboluminescence. This one's about our senses.
Go on, I'm listening.
Okay, picture this. You're about to crunch a wintergreen lifesaver, ready for that spark. But does the sound of it breaking change how we see the light?
That's a really interesting question. It's about sensory integration, how our brains take in information from different senses and put it all together.
So you're saying the sound of the crunch could actually make the spark seem brighter?
It's definitely possible. Our senses don't work separately. They're always talking to each other and influencing each other.
This is blowing my mind. I never thought about the sound playing a role, but it makes sense. We connect certain sounds with certain visual things all the time.
Exactly. Like fireworks, right? The light show is way more intense because of the booming sound.
Or the sizzle of a steak on the grill, it just makes it look more delicious.
Exactly. Our brains are wired to link those sensory experiences.
So when we crunch that lifesaver, the sound of the breaking crystals could be telling our brains to expect a spark, and that makes the light seem brighter.
It's a good theory. It shows how complex our senses are and how they work together.
This opens up a whole new world of possibilities. Could we use sound to make triboluminescence seem brighter? Could we create experiences that combine light and sound in new ways?
Those are great questions, and they're perfect for scientific research.
I'm picturing art installations with triboluminescent materials and sound.
The artistic potential is huge.
And think about safety signals. Could we make warning lights that are both bright and loud so they're super effective in emergencies?
Definitely worth looking into.
This is what I love about science. It's full of surprises. And every discovery leads to more questions and more possibilities.
It reminds us that even in a world that can feel predictable, there's always something new and amazing waiting to be found.
Well said. Now let's focus on one last cool thing about triboluminescence.
I'm all ears.
We've been talking about triboluminescence like it's this rare special thing. But what if it's happening all around us, all the time, and we just don't see it?
Now that's an interesting thought. Tell me more.
Think about everyday things, like peeling tape or cracking your knuckles.
Those things do make a little bit of triboluminescence, yeah, but it's usually too faint to see.
Exactly. But what if we could make that light stronger? What if we could see the invisible?
That's a challenge, but it could lead to some cool discoveries.
Imagine seeing the stress in a bridge as cars go over it, or the tiny cracks forming in metal as it bends.
It would be like having X-ray vision for the forces that shape our world.
And it could totally change fields like engineering and materials science.
The potential uses are huge.
So while we're looking for triboluminescence in fancy materials and big events, let's not forget about the amazing stuff that might be right under our noses.
It's a reminder that there's still so much we don't know about the world, and even the simplest things can hold incredible secrets.
Well said. And on that note, I think it's time to wrap up this deep dive.
I agree, but before we go, let's leave our listener with something to think about.
Intrigued. Tell me more.
We've explored the science behind triboluminescence, what we could use it for, and even how it might be working in nature.
It's a phenomenon with many sides.
For sure. But here's the question I want our listener to ponder. If triboluminescence turns movement into light, could we do the opposite? Could we use light to make things move?
Whoa, that's a tough one. You're talking about using light to move things like a tractor beam from Star Trek?
It might seem like sci-fi, but some researchers are looking into using light to manipulate matter at really tiny scales, like nanometers.
So instead of crushing a crystal to make light, we could shine light on it to make it move or change shape.
It's still very early research, but it has the potential to revolutionize all kinds of things, like robotics, medicine, and even how we make things.
That's an awesome thought to leave our listener with. The same thing that makes a lifesaver spark could one day power machines with light.
It shows us that the limits of science are always changing, and what seems impossible today could be real tomorrow.
I can't wait to see what the future holds for triboluminescence and all the amazing things we'll discover.
Me too. I have a feeling it's going to be bright.
Light-powered machines. That sounds like something straight out of science fiction.
It does, doesn't it? But, history's shown us that what's sci-fi today often becomes reality tomorrow.
I can already picture it. Triboluminescent cars, like powered by the friction of the tires on the road.
That's a pretty wild vision of the future, but while we're imagining things, let's not forget about triboluminescence in nature, like right now.
You're right. We got so caught up in the what-ifs that we haven't really talked about how this stuff might already be happening in the natural world.
There's still so much we don't know, but there are some really cool hints that triboluminescence might be part of a bunch of natural processes.
Like, for instance, I read about some sea creatures that can make their own light. Bioluminescence, right? Could triboluminescence be part of that?
It's definitely possible. Just imagine a school of fish swimming in the deep ocean, the friction of their bodies against the water making tiny sparks.
Wow, that would be an incredible sight, like a natural light show.
And think about what it could mean. Maybe they use it to communicate, or to hide from predators, or even to attract mates.
Nature's disco ball, I love it.
And then there's the geological stuff we talked about earlier. Earthquakes are a big one, obviously, but what about volcanic eruptions? Or meteor impacts?
The forces in those events are insane. It makes sense that triboluminescence could happen in those situations.
Exactly. The pressure and friction could make flashes of light deep inside the Earth, or even in the dust cloud of a meteor hitting the planet.
Makes you wonder how much triboluminescence is happening all the time, right under our noses, but we just can't see it.
It's a good reminder that we've only just begun to understand this phenomenon. There's so much more to learn.
This whole deep dive has been awesome. We've gone from the science of triboluminescence to the potential uses to its possible role in nature.
And we've found connections to things like the FDA and how our senses work. It's been a journey through all sorts of different areas of science.
And speaking of discoverers, we got to give a shout out to the wintergreen lifesaver.
Those little candies have definitely earned their place in triboluminescence history.
They're a perfect example of how something totally ordinary can spark curiosity and lead to a deeper understanding of the world.
And a tasty reminder that science is everywhere, even in candy.
So to everyone listening, keep your eyes peeled for signs of triboluminescence in your daily life.
You never know when you'll find a spark of inspiration or a flash of insight or a glimmer of understanding.
And remember, even when things seem dark, there's always a bit of light waiting to be discovered. Just got to know where to look.
Well said. It's been a blast exploring the world of triboluminescence with you.
Until next time, stay curious, keep exploring, and never stop searching for the amazing things that make our universe so incredible.